In this video, we'll be doing about estimation of hardness, and this estimation of hardness of the hard water will be done by EDTA method. So now EDTA is supposed to be ethylene diamine tetraacetate, and then in this method you will be making use of ethylene diamine tetraacid. So you will be making use of this compound to determine the hardness. So now we'll discuss the basic procedure which is involved in the titration. So you carry out a titration to determine the hardness. So now in the calculations part, it will be clearer for you on how this method is helpful in determining the hardness, and then what unit you make use of, which is obviously either ppm or milligram per liter. These two are the basic units that you make use of. So before that, you will do certain details on the burette solution. So now here, first of all, your burette solution is EDTA is supposed to be the burette solution, and then the full form is ethylene diamine tetra acid or tetraacetate. Like let's take tetraacetate in the beginning, and then now let's draw the structure. So now let's draw the structure. So now first thing is ethylene. Now while drawing the structure, you really don't have to memorize the structure as such. You have to just follow the name, follow the full form. The first one is supposed to be ethylene. So now the structure of ethylene is just CH2 double bond CH2. And now next is diamine. So now when two amine molecules are being added to this, or the word addition is the appropriate word and word substitution is not appropriate because it is across a double bond. So it is added and not substituted. So one double bond is removed, and then you will be having H2 here, N, and H2 here, and then N. And then you have tetraacetate molecule. Tetraacetate molecule is 4 acetate molecules. So for that you will remove your H2 here. So two of the acetate molecules can be included, and then here you can remove 2 of hydrogen atoms, and then you can have acetate molecules instead. So this is how it will be, and then you need to write the acetate molecule. So now what is the formula for acetate? I am writing it as A so that it will be easier for me to finish the structure. A is CH3COO minus. This is only the acetate molecule, acetate anion. I am use the word molecule very frequently. Anion is it's the proper word. It's the most appropriate word. So you can write A all over. That is tetraacetate. This is the structure of ethylene diamine tetraacetate, which is made use in this experiment as the burette solution. And then afterwards, this is the first thing is your expansion. Second thing is the structure which I wanted to talk about. Third is certain facts. It is a hexadentate ligand. That means number of ligands here are 6. So now and then you know how you will determine the number of ligands, which we have learned it under complexes chapter. Here the number of ligands are 6, 4 of which will be from your acetate molecules. 4 of which will be from your acetate molecules, and then the other 2 will be from your nitrogen. So now there will be a hexadentate ligand. That's one more name for this ethylene diamine tetraacetate. So hexadentate ligand, and then afterwards, apart from that, next is the structure, which is a must for you to know, and then next is supposed to be the full form. So now these are the details regarding the burette solution, and then afterwards next is your pipette solution. So burette solution is EDTA. Pipette solution will differ depending on the case you take up. There are totally 3 titrations that you will have to carry out to determine the temporary hardness, permanent hardness, and total hardness. But then the first titration will have a different purpose. The first titration's purpose is to determine the concentration of EDTA. So concentration of EDTA is a must, so that only on the basis of this concentration or the strength of EDTA that you determine in the first titration, the values in the second titration will change or will be formed. So for the values of the second or the third titration, you need the concentration of EDTA which is obtained from the first titration. So for burette solution you have EDTA. Pipette solution, either you will have first is one hard water, and then next is the general water sample, and then the third one is supposed to be boiled and filtered sample. This water sample is the same as the hard water which I have mentioned here, but then this water sample that you make use of in the second case will compulsorily have both temporary and permanent hardness. So both temporary hardness and permanent hardness, which is total amount of hardness, will be present in general water sample. This hard water will not have a proper specification because you use this hard water to determine the concentration of EDTA. So now in this first case, let me write the purpose also as clear as possible so that you will not get confused. Here the first one is to find the okay, I don't think it will be clear. So while explaining the steps separately, I'll mention that. So orally I'll mention first hard water is made use of to determine the concentration or the strength of EDTA, and then next one is supposed to be general water sample is made use of to determine the total hardness. So you will have to determine the concentration of the general water sample, and then you will determine the total hardness. For this boiled and filtered sample of water, you will use this sample to determine the permanent hardness. This water sample will have just salts causing permanent hardness and not the salts which causes temporary hardness, but the water sample of this will contain salts causing permanent as well as temporary hardness. This is a general sample where the varying amount of salts will be present. So you will make use of these three solutions in the three cases, and then the volume of this which you make use of is 20 ml. The volume that you make use of in this case is 20 ml, and apart from that you will add 10 ml of EBT, and then afterwards, after you add 10 ml of not 10 ml of EBT, I'm sorry, extremely sorry for that, it's 10 ml of NH4Cl, and this NH4Cl is supposed to be a buffer, and pinch of EBT. So 10 ml of NH4Cl. 10 ml of NH4Cl is ammoniacal chloride. And that is supposed to be a buffer. So what is a buffer? A buffer is supposed to be a substance which will resist the change in the pH if an acid or a base is added. In this case, you add EDTA, which is an acid. The pH will definitely go below 7 because you know that acid develops such a change in pH. So this is a change created by the acid in the pH levels. So when you add a buffer like ammoniacal chloride, what happens is that the pH is balanced, the pH is regularized. So this is because of the effect of buffer. So you add 10 ml of ammoniacal chloride, which is a buffer, and then you add a pinch of EBT, and this EBT is eriochrome black tea. So now what is the full form? The full form of EBT here is eriochrome black tea. Eriochrome black tea is supposed to be the indicator in this. In this case, eriochrome black tea is the indicator, and that will indicate the change in the color, so which will give you the concordant volume in the end. And then you will be adding 10 ml of buffer, which is to balance the pH after this EDTA has been added. So now, before I go on with the calculation part, let me just mention about the end point. So now the end point will be wine red to steel blue. So what happens is, first you take your pipette solution. That means you pipette out 20 ml of these samples depending on what titration you are carrying out. Apart from that, you pipette it out, and when you pipette it out, what happens is you will have to add 10 ml of the buffer solution, and apart from that you are supposed to add the pinch of EBT. When you add this pinch of EBT and when you mix it, you will be getting a red wine color. and then you carry out your titration, which is you titrate EDTA, you use this as a burette solution. That means you titrate the conical flask substance against EDTA. So when this EDTA starts falling here, a complex is formed. So already hard water has calcium and magnesium. Okay, before I come to the calculation part, let me explain the theory once again. So now this is a change in color that is observed. So initially you have a conical flask, and then it has certain substances, and now the substances will always have calcium and magnesium cation. So afterwards you add EBT and NH4Cl. So now you have your Ca2 plus and Mg2 plus, and then with that you will be having EBT as well. It forms a complex. After the complex is formed, you will be getting a wine red color, as I've already mentioned before. So now the next one is, after now you will have to carry out the titration. So as I've told you before, you will have to carry out the titration. When this EDTA combines with the complex which is already formed, a steel blue color is obtained. So initially you add the calcium and magnesium cation, and then afterwards you will add EBT, and then when you add EBT, what happens is that a calcium, magnesium and EBT, all three things together will basically form a complex, and this complex will be red wine in color. And then afterwards, when you carry out titration, slowly this EDTA will again enter the complex, it will form a new complex, and this new complex in the end will be steel blue in color. So this complex will be steel blue in color, or it can be dark blue. Dark blue is probably an appropriate word, because that is the color which will be visible to you. Okay, so now this is it about your basic procedure. This is about a basic procedure, and then after that next is your calculations. So the way you calculate, no matter what titration you do, you will be having M1, V1, M2 and V2, and this is always for your pipette. M1, V1 you can take it for pipette, and M2, P2 you can take it for burette. So now for pipette, in all the cases your values will keep varying obviously. So now for pipette solution, in the first case, so when you take the first case, what is the first case? The first case is using hard water. So as I've already told you, when we make use of hard water in the first titration, our main aim is to determine the concentration of EDTA. So the main aim is to determine the concentration of EDTA. So in that case, your pipette solutions value will be given. So now generally 0.01 is the value that is generally given to us, and V1 is always 20, and M2 is nothing but the concentration of the burette solution. Concentration of burette solution is nothing but the concentration of EDTA. Concentration of EDTA is the one which must be found in the case of the first case. First case is where you make use of hard water. So this is a question mark. You are supposed to find it. And V2 is supposed to be concordant volume. This is a concordant volume. So now using the formula M1 V1 is equal to M2 V2, you can determine the molarity or in the concentration or the strength of EDTA, and you make use of hard water in this case, and then your calculations will get over with that itself. When you take the second one, which is general water sample, in the second titration you make use of general water sample, but here your main aim is to do two things. First thing is to calculate the strength and the concentration of the general water sample by making use of the concentration of EDTA which you have already found in the first case. And then next is to find the total hardness. So now let's see. You know M1. M1 is nothing but your pipette. Now first we are seeing pipette. M1 is not M1 is actually not known, because you know that M1 is nothing but the concentration of the pipette solution, but you don't know what the value is because you're supposed to find it. So B1 is 20. So now let's come to burette. M2 is your concentration of EDTA. V2 is concordant volume. So now here concentration is concordant, okay, I write concordant volume. So now using this you're supposed to find M1, and after you find M1 using the formula, next is supposed to be the method of finding your total hardness. So now how do you find total hardness? So now total hardness is nothing but M1. M1 is supposed to be the one which you are supposed to find. M1 is the concentration of the pipette solution. M1 into 100 into 1000. So when you use this equation, or you can just write it as M1 into 10 to the power 5. 1, 2, 3, 4, 5. So M1 into 10 to the power 5. So when you make use of this equation, you will be getting your hardness, which is total hardness. Total hardness will be obtained, and this is in terms of ppm. So you will make use of ppm for finding your total hardness. So now next is supposed to be the calculations involved in your third titration. So now for calculations involved in third titration is the same thing. You are supposed to find the concentration of the boiled and filtered sample. So now you might ask me, why am I supposed to boil it? Why am I supposed to filter it? But what we generally do in lab is we do not follow any such things. It has already been boiled and it has already been filtered by the lab itself. So in most of the cases, the sample that you make use of is already boiled and filtered sample. But just for the sake of clarity, while writing the procedure, it is always good to write boiled and filtered sample. So in the boiled and the filtered sample, you actually take 20 ml after you pipette it out, and then this 20 ml, for this 20 ml you are supposed to find the concentration as you have done here. And again, as you have done here, you are supposed to find the hardness. But here hardness is not total hardness. Here the hardness is permanent hardness alone. Here you find the total, here you find the total hardness, which is permanent plus temporary. You find both together. But here you find only the permanent hardness. Apart from that, you find the concentration of the water sample that you make use of. So now M1 you are supposed to find, as I told you right now. V1 is always 20. M2 concordant, which is your concentration of EDTA, and then this is the concordant volume. So you find M1. Again you follow the same formula, but then this is for permanent hardness. So permanent hardness will be M1 into 10 to the power 5. Now you have got permanent hardness, you have got total hardness. It is very simple to get temporary hardness, because total hardness is equal to permanent plus temporary. So now you take this to the other side and then you find the difference. So now your temporary hardness is equal to M1 T, because M1 is there in both the cases. In both the cases you have considered M1 as your the one which you are supposed to find, the value which you are supposed to find. So you can take it as M1T, which is supposed to be total hardness, minus M1P, which is a permanent hardness, into 10 to the power 5. If you make use of this, you will be getting a temporary hardness. So you will get your temporary hardness, you will get your permanent hardness, you will get your total hardness, you will get concentration of this solution, general water sample solution, you will get concentration of boiled and filtered sample solution, you will get the concentration of EDTA in the end of this experiment. So after discussing all these things, if someone asks you what is the main aim of this experiment, the main aim of the experiment is just to determine or estimate the hardness present in water, and then to classify, you take the sample and then you find what the temporary hardness is of this water, what is the permanent hardness of this water, therefore what is the total hardness. So this is the basic method that you will make use of to determine the hardness present in the water. So you will have to follow all these procedures. So a very quick recap: you take a burette solution, which is EDTA, you take pipette solution, which is in the first case, which is to determine the concentration of EDTA, you make use of a general hard water. It has a mixture of salts. And then in the second case, you make use of general water sample. This general water sample will have a mixture of all the salts causing permanent as well as temporary hardness. That is a pipette solution for the second case, second titration. For third titration, your pipette solution will have salts which are responsible just for permanent hardness. That means magnesium chloride, calcium chloride, magnesium sulfate, calcium sulfate, and so on. All these salts, all these samples are taken in a volume of 20 ml by pipetting it out using the instrument. And then you add 10 ml of ammoniacal chloride, which is the buffer solution, which is to maintain the pH. And then you add a pinch of EBT, which is eriochrome black tea. And then eriochrome black tea will react with calcium and magnesium to form a complex. This complex will give rise to a red wine color. When titration of EDTA happens with this complex which is formed, which is there in your conical flask, which is indirectly your pipette solution, you will be getting steel blue color. This is because of the reaction of that complex form, which is red wine color with EDTA. And then you know how to calculate your concentration in all the three cases, which is the first case for EDTA, second and third case for the pipette solution. You calculate the concentration, and in the second and third condition or the titration, you calculate the concentration and multiply it with 10 to the power 5, and then you will be getting your hardness, which is total hardness and permanent hardness. Subtract it, get your temporary hardness, and there ends your experiment. So in the next video, we'll be doing about certain basic numericals on how to determine the hardness in water depending on what salts are present, and then a brief description about what are the formulae that you use in these basic sums. And then in the subsequent video, you will be doing about the disadvantages of hardness, and then we will enter into the most important topic, which is boiler troubles. There are a lot of disadvantages of using hard water in boilers. A discussion on that also will be done. So thank you so much.